Alkanes as our first homologous series. Like I said, in organic chemistry, we are going to be looking at homologous series. We are going to be looking at homologous series. So the first one we are looking at is alkanes, and you're saying the hydrocarbons which form a homologous series that is saturated in nature. That means everywhere there are single bonds. We do not have multiple bonds in alkanes, and they have a general formula. And the general formula I'm saying is CnH2n plus 2, where n is an integer starting from 1 up to as many as you can go. Because of catenation, carbon is able to bond with itself, forming multiple products or multiple compounds. And we're saying that the compounds differ from each other by a methylene group, which we have called CH2. We have two main sources of alkanes. We have two main sources of alkanes. The first one is natural gas. Natural gas contains mainly methane. It contains mainly methane and a few of butane and propane. But mainly natural gas is methane gas. Then we also have petroleum products. Of course, these ones are as a result of refining of petroleum, you end up having many other alkane compounds coming from petroleum. Okay, now we want to look at nomenclature of alkanes. Nomenclature is the same as naming. We want to look at how to name alkanes. And we are saying if you want to name alkanes, you are going to consider two cases. There are alkanes which are straight chains. There are also alkanes which are branched. We are saying for straight chain alkanes, we just attach the suffix ane at the end of the name. Of course, depending on the number of carbon atoms. If the number of carbon atoms is 1, methane, 2, ethane, 3, propane, 4, butane, 5, pentane. Just like that. We just keep adding ane, depending on the number of carbon atoms. Whereas if they are branched, the compound is branched, then what is important is mentioning the position of the substituent or the branch. Of course, in most cases, the branches are going to be a methyl group or an ethyl group. The compound can be so big and you might end up having a propyl group as a branch. But what matters is knowing the position. Now we are saying that in this case, the substituent must take the smallest position of that carbon atom in a compound, as we are going to see in the examples. Okay, so we have said when n is 1, that is CH4, we have called it methane. When n is 2, that is C2H6, which is actually this is the molecular formula, this is the structure formula, and we have actually called it ethane. We just keep adding suffix ane. When n is equal to 3, we shall have C3H8, and then the structure formula is going to be CH3. We just add a methylene group in the middle, and that one is going to become propane. When n is equal to 4, that is C4H10, and that is going to be CH3, CH2, CH2, CH3. That is butane. When n is equal to 5, C5H12. Remember, I am following the general formula CnH2n plus 2. That is the general formula that I am following. So I'm just substituting for n, and that is going to be CH3, CH2, 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 CH3, and we call that one pentane. When N is 6, it's going to be hexane. When N is 7, it's going to be heptane. When N is 8, octane. Nonane when N is 9, decane when N is 10. And of course, as you're continuing down the names, what matters most is the suffix ane is what matters. The other thing we must take note is that from N is equal to 4 downwards, all these compounds are able to form isomers by branching, which we actually called chain isomers. For example, I'm going to use steel for N is equal to 4. N is equal to 4. These ones now are branched compounds. And these ones are branched. For N is equal to 4, we say that is C4H10. H10. We say this CH3 can come to this carbon here. And then it becomes CH3, CH3, this hydrogen, it comes here, then this CH3 comes here, CH3. And you say, when we are naming this compound, we have to make mention of the position of the branch on the main chain. For example, this methyl group is on carbon number 2. If I name from this side, number 1, number 2, number 3. So the methyl group is on carbon number 2. Even if I begin from this side, still it will be carbon number 2. And in that case, I have to make mention of it. I say 2 dash methyl, because the branch is the methyl group coming from methane. So I just add methyl. 2 methyl, then the longest chain has 3 carbon atoms. It's a propane. So that's how we name branch compounds. We can look at when is equal to N is equal to 5, and we look at the kind of branching there. So I want to look at the branch for N is equal to 5. We have called it C5 H what? H12. C5 H12. If you can take a look at it from here, this last methyl group can get attached to this carbon or this one. So if I bring it here, I would have CH3, you see that? Then CH, I bring my CH3 here, and then I just complete CH3, CH2, CH3, whereby one of the hydrogens here has come to complete here. So in this case, when I'm naming this, I have to put the numbers. In that case, I can put the numbers like that, but I can also start a numbering from this side, 3 and 4. But we say that the branch must, when we are naming, must be attached to the carbon in its smallest number. So in this case, you see that this carbon can take either position 2 or position 3. So we choose position 2. So the numbering is going to begin from this side. And then we can say that it is 2 methyl. The longest chain now will have 4 carbon atoms, then it becomes butane. It becomes butane. Sometimes the chain can be adjusted to confuse you. In this case, it can be CH3, CH, then CH3, then we have down CH2, CH3. They have just tried to confuse you in that case, but it is important for you to note that this compound and this one, they are the same. In this case, they are the same. Whereby you must, when you are naming, you must locate the longest chain. The longest chain is the one that determines the name of the compound. In that case, the longest chain, I can choose to consider this. So the longest chain will have 1, 2, 3, 4 carbon atoms. It means if you consider the longest chain as this one, the horizontal one will have only 3. Do you see that? And therefore it means that in that case, if I choose this one as my longest chain, then this one will be the branch. But still the branch, the methyl branch, is still on carbon number 2 if I start from this side to give numbers. Number 1, number 2, number 3, number 4. It means my branch will be on carbon number 2. So still it will be 2-methyl butane, which is the same. So sometimes they can just adjust the structure, but the compound remains the same. So before you identify the branch, first identify the longest chain. First identify the longest chain. Okay, that is it. One more scenario. For n is equal to 6, that is C6H14. Of course, we can have hexane, but I want to create different branches. I can have five of them. If I have 5 of them, then I can create a branch here. If I create a branch here, this will be CH3, CH2, this will just be CH, CH2, CH, this will be CH3, and then I have CH3. If I'm naming this, the longest chain has 5 carbon atoms, and therefore it's going to be pentane. But now I must mention the position of the branch. The branch is on carbon number 3, either from this side or from this side. It will still be carbon number 3. So this one will be 3-methyl pentane. 3-methyl pentane. I think that is okay. However, I can also bring this CH3, I attach it here, and that will be C. This one already has a CH3. I am bringing this methyl group, I'm attaching it here, CH3. So this will be CH3, this will be H, this will be H, this will be CH3. This still has a total of carbon 6 of them, right? The hydrogen, of course, they are 14. But now the branches are 2. I have a branch here and I have a branch here. So if I want to name in this case, I'm going to start naming, counting my carbon atoms. I have to give them numbers so that I can identify the position of the branches. If I start from here 1, 2, 3, 4. If I start from here 1, 2, 3, 4. Which numbering I'm going to take? I'm going to take the numbering such that the position of the branches is the smallest summation. For example, when you look at the position here, this is position number 2, this is position number 3. So both of them, when I add their position, is 5. If I take the numbering from this side, this will be position 2, this will be position 3, still it will be 5. So it means from anywhere I start, still the number, the naming will be the same. So probably I can begin from this side, just for uniqueness. So I'm going to say the first methyl group is on position number 2, the second methyl group is on position number 3. So in my naming, I'm going to say 2, 3, then dash, right? The groups are methyl groups, so I'll call them dimethyl because they are 2. Dimethyl. Then the longest chain has 4 carbon atoms. That will be butane. That will be butane. So, what if the branches were on the same carbon? What if the branches were on the same carbon? That will be our last illustration. For example, I can have CH3C, then here, methyl group. This methyl group, I'm bringing it here, CH3, and then that will be CH2, CH3 is still the same. But in this case now, I'm going to consider starting from this side so that this carbon with the branches will have the lowest number 2. And So I would say the first branch is on carbon number 2, but the second is also on carbon number 2. It's not a repetition. That is how we name them according to IUPAC named. Then I will still call it dimethyl. The longest chain is butane. So how do you differentiate this compound from this? Of course, you look at the position of the methyl groups. This one shows that both methyl groups are on carbon number 2, whereas this one shows you that both methyl groups, one is on carbon number 2, the other one is on carbon number